Hello. In this one, we're going to look at the attribute filter node. This node allows you to filter points based on their attribute set data, which looks like this. You can use a variety of different operators to compare attribute values with a constant threshold, another attribute, blueprint variables, and other data types. It's a super useful node and easy to use once you understand what it expects and how it functions. So let's take a look. We're going to use the standard setup here for these tutorials. Make sure you got PCG enabled. Let's go to the plugins menu, type in PCG, and then turn these on. I'm going to right click over here and create a blueprint, class actor. Right click again, go to PCG. I'm going to create a default empty graph. We'll open up the blueprint. Here in the component section, we're going to add a PCG component. You'll see a little graph section there. We'll just drag the graph in and compile and save. Let's go ahead and drag an instance of our blueprint into the level and open up our PCG graph. And I'm just going to right click in here and type in points grid. This is going to create a points grid. I'm going to hide the floor just to kind of get it out of the way. And if I hit the D key on this points grid to debug it, we see here a bunch of points at the origin. If I tap the A key to inspect this node, we will see there are 100 points in here starting at 0. And you can see over here 100 out of 100 entries. So by default, we're going to get 100 points with a points grid. But I would like for them to be at the location of the blueprint. So I'm going to add a get actor data node. I'm going to set this to get single point. And if I tap the A key on this, we can see we've got a position of 390, negative 1000 and change, and negative 1 in Z. And if I select the blueprint, we can see that that's our location. So now I'm going to add a copy points node. We'll take the points grid, plug it into the source, and the actor data, and plug it into target. And if I debug this, again with the D key, we can see now the points are being copied to the location of the blueprint. And we'll turn off my various debugs. Let's make a couple of modifications here. On the points grid, I want to set this to 500. That'll give us a cube shape there, and if I come over to copy points is fine. I'm going to go down to the debug, turn on absolute, and set this to 0.2. And now we can get a better look at our actual point grid here. And now we can add an attribute filter. So at its simplest, what we can do is we'll just do a little index filter here. So I'm going to set the operator to greater than. If we tap the A key, we can see we now have 1,000 entries because we increased the grid size there. So if I say for the target attribute, we're going to be looking at the index, I'm going to use a constant threshold, and I'll just set this to 500. And then I'm going to add a debug node. And we can see that what this filter is doing is basically saying anything with an index that is higher than 500 we're going to keep, and anything that's outside the filter, you can access that as well if you want. Let me just tap the E key on this to disable it. So this is just a very simple binary, right? Like if the index is greater than 500, then we pipe them out the inside the filter. Otherwise, everything's going to get piped out the outside here. Okay, we'll keep our little debugs here, and we'll look at something a little bit more complicated. I'm going to scoot this over here. And I'm also going to set this to absolute, and we'll do like 0.2 on that. Actually, I guess that's on these, isn't it? One of the things about the filter attribute elements node here is it will not show you the output result. Like if you hit debug on it, you're just going to see everything that's coming in. So you've actually got to set your debug up to have the points scaling the way you want them to scale. I'm going to turn off enable on that one. So what I want to do is I want to use the distance between the blueprint's location, which is going to be the center of this point grid, and each of these points so that I can basically filter out any point that is beyond a certain range. So I'm going to add a distance node. I'm going to pipe the actor data into the target and the points here into the source. And if I tap the A key to inspect and scoot this over a bit and scroll over, what we find here is in the attribute set data, we now have a new attribute, and that's where this thing gets really useful because we can easily compare attributes. So I'm going to switch from the target attribute from index and set it to distance. And I'm just going to do a quick sort here. Looks like our minimum distance is going to be 79 units and our max distance is going to be about 700. So if I set this to something like 350, it will help. So what this warning is basically saying is it doesn't have a distance attribute because I'm not piping it in. So let's do that. And what I want to do is set this to less than. And there you go. So it looks a little bit weird, but we're basically filtering out any points that are further than 350 units from the location of the blueprint, which I can update by scooting this thing around. Very simply, because this node here automatically adds this distance attribute into the attribute set data. You can use an add attribute node, and you can call it whatever you want and pipe in whatever data you want, and then use that, whatever you've named it here in your output target, right, ASDF, as your filter name. So it's very powerful in that regard. Let's extend this a little bit. Rather than using a constant threshold here, what I'm going to do is I'm going to create an attribute. And plug it in. We'll go ahead and hit save. And so into this attribute, I can now type in whatever value I want, and we can see that update. But where this gets really cool is if we create a variable exposed on the blueprint so that we can control this value outside of the PCG graph. So I'm going to come over to the variable section and create a variable called call distance. I'm going to set its data type to float. Very importantly, make it public so the PCG graph can access it. Call distance. And our actor property here, property name is going to be call distance. And let's set the default value for call distance to 300. And now directly here on the blueprint itself, we can control that data without having to know anything about PCG. So very, very helpful. Let's take a look at some practical use case examples here of the attribute filter node. I thought it would be interesting to try to build some rose windows like you might find in a cathedral using PCG. The stonework is all created procedurally with PCG, and the glass is built using geometry scripting. I have some tutorials that I will link up in the corner here. This is what that graph looks like. It's not too bad, but if you don't know what you're looking at, it's probably not that useful. Here is the primary graph for the spokes. I'll just zip over to my standalone demo here. It's constructed of three primary components. There are the concentric circles, which are going to be these elements here. There are spokes, which are the straight elements here and along the outer rim here. And then there are circles that have a different center point that is controllable, and that's going to be these elements there and these elements as well. So we'll take a look here at the spokes subgraph. We start off with a couple of points. One of them offset some value in y, and one of them offset some other value in y, which is going to give us a straightish line here. See if I've got my debug up. So there are a few instances of this graph, so we've got a few different lengths there. And then these points are going to get rotated. This is a very, very handy node here, this rotate around axis. It's pretty easy to use. There's one little gotcha. If this is disconnected, it sure looks like a vector, but if you plug in a vector, it's going to break, so you've got to just give it a float value and it'll work. So that's going to give us our ring configuration. And then this just copies these points over to wherever the blueprint happens to be parked. Let me turn this debug off there. So what I wanted to do was to be able to optionally decorate either the start or the end of the spoke. So I needed to isolate those points, the first and last element here, last point. So to get the end, what I need is the points count. You just type in points count. What it'll do is it'll automatically create an attribute called num entries. And because we start our count at 0, I've got to subtract 1. And then I can filter all of the elements that aren't equal to my num entries attribute, right? This should all look pretty familiar. If I hit the debug on this, you can see, let me clear that one out. Right, just the ends there. And this one's a little bit simpler. We really just need the index that is 0, which is going to be our first one. So if I tap the D key on that one, oh, maybe I probably don't have the scale set up properly. Yeah, there we go. So there's the start point. And then I'm just creating some named reroutes so that I can reference these up here. This is where the actual decorators are added using the static mesh spawner. Let's run through the setup on these real quick. We have 2 named reroutes here. These are coming from our graph inputs. You can see there they are, decorate spoke start and spoke end. And all it looks like is there's the label for it. We're going to set it to attribute set, and then the pin status is normal, so it's always visible. And then out here, this is kind of what it looks like. And what this is expecting is a soft object path to a piece of geometry. All right. So zipping back over here, what I am doing is adding an attribute here, which is that path. So if this path exists, the attribute will be added. And then the filter attribute node is going to look to see, hey, do I have a static mesh attribute? And over here, the attribute name is going to be static mesh. This is arbitrary. This can kind of be whatever you want. So anyway, if this data exists, it'll get passed through. If it doesn't exist, nothing will happen. And to avoid an error, you have to, or a warning anyway, you've got to disable this option here. If we don't care that there's no data coming in, then I don't need to see that warning. Otherwise, it's going to have that little yellow bar there. And then in the static mesh spawner, rather than using the actual, so you can pipe a mesh directly in, what I want to do here is I actually want to use PCG mesh selector by attribute, and then the attribute name is going to be static mesh. So what that means is out here, if I wanted to pass in a different static mesh, it's not difficult to do so. So I'm going to create an attribute. We'll come over to the type, set it to soft object path. Scoot this out of the way for a second. I'll grab this one, pipe it in, and scoot this over, and then plug it in. And you can see as soon as that data becomes valid, now we have our little points having some decorators on them. And if we hop back over into our build spokes graph here, if I toggle through, you can see now that point data is valid. So filter attributes is super useful. I use it all the time. It's probably one of my core go-to nodes. I hope you found this tutorial to be helpful, and please feel free to leave any questions in the comments below. And thank you very much.